Hi, everybody. Yes, I am Pam Lahoud. I am the lead program manager for SQL Server on Azure Virtual Machines. And over the past year, we're relatively, our team is relatively new to this business. We've been doing this for about just over a year. So it's been a lot of ramp up and drinking from the fire hose here. And so over the past year, we've been really feeling out customer pain points and finding out where people are having challenges. And obviously storage is one of those. So we've been doing a series of presentations. We've done some videos on data exposed. We've done some data exposed live shows. And we're really just trying to get the message out about what we're learning about what's different about running SQL Server on Azure Virtual Machines. And so for this one, because everyone is expecting brain melting content, there's not a whole lot brain melting about Azure VM, but what I wanted to do is dig a little bit deeper into how storage works in Azure, because it is quite different than what you're probably used to on-prem. So that's what we're going to do today, is talk about how storage works in Azure when you create a virtual machine, and what the implications of that are for you when you're planning either like an on-prem migration to Azure VM, or some folks even going with brand new deployments in Azure VM. So that's what we're going to talk about today. So I don't have much of an intro slide. I'm SQL Goddess. You can find me on Twitter if you have any questions or follow up or just want to chit chat. I'm not a great tweeter, but if someone tweets at me, I definitely try to respond. So that's where you can find me. I've been with Microsoft for 15 years, so I've been doing SQL Server for a really long time. So that's the most interesting part of my bio. Okay. So let's dig in. Oh, last thing. Thank you to Ree and Melody for doing the moderation today. And like I said earlier, in case you're just joining, do feel free to ask questions throughout the session, and I will try to take them in line if I can. And then I'll hopefully leave some time at the end for any additional questions. So definitely ask away if you have questions. Okay. So if any of you have seen the data exposed sessions that David Pless and I have been doing, some of these slides may look familiar. I've basically taken David's presentation on IO and sizing, and I've kind of mixed a whole bunch of stuff together, and I've added a little more deep dive content here. So that's where this presentation comes from. So the main message that we've been trying to get across is that the way you think about sizing hardware for SQL Server is different in Azure than it is on-prem. And this seems to be the root cause of a lot of performance challenges that customers face when they move into Azure VM. And we're noticing just kind of a methodology of the way people think about hardware. So when you're on-prem, you're generally buying in 5-year cycles. So you're buying more hardware than you need for your current SQL Server workload, because it's that whole CapEx versus OpEx expense thing. So you're planning ahead to make sure that you have room for growth for years. And that methodology and that mindset actually works against you when you start moving into Azure, because when you're in Azure, you're effectively renting the hardware, right? You're paying as you go, you're paying per minute or per second even. And you want to be thinking differently about how you're sizing and how you're configuring things. Obviously, you need to have enough, enough resources to sustain your workload without having any performance issues. But also you want to make sure that you're not oversizing, because that's going to end up costing you a lot of money. So when it comes to this price performance ratio, there's a lot of nuance to this, and there's a lot of details that are important for you to know about how Azure works, and particularly how storage works in Azure, in order to get this right. And so that's kind of what we're going to talk about today, is how storage works, how you need to think about sizing, and how you need to pivot a little bit the way you think about sizing for SQL Server, because you're not going to have this giant SAN that, like a lot of you may have, you're doing enterprise level stuff. You may have giant SANs and they're super fast, and you've got more than enough storage, and you've got IOPS and throughput to spare, and you're just not worrying about this problem the same way you're going to have to think about it in Azure VM. So that's kind of the background here of what we're going to talk about. So let's start with the various disk options and the way disks are configured in Azure VM. So if you spin up an Azure VM straight out of the marketplace, and this is without SQL Server, this is just VM, or if you choose a SQL VM, it's the same. If you look at the disks, you'll end up with essentially 3 different types of disks. You'll have an OS disk, and this will be your C drive. This is remote storage, so it's not local to the VM. It's hosted in the as a managed disk, what we call a managed disk. It's persistent, and it will have an operating system pre-installed on it based on the image, the base image that you chose. So it could be Windows, various flavors of Linux, you know, whatever you choose, that will be pre-installed on the C drive. So that's your OS disk. Then you will have a D drive, a temporary disk. Most Azure VMs have a temporary disk, but not all. There are some VM sizes, and it depends on the series and the size that you choose, that may not have a local drive. What we will tell you, and I'll probably reiterate this many times throughout the day, is we highly recommend that you choose a VM size that has a decent sized local disk, a temporary disk, because this is a great place for you to put TempDB. So that's a recommendation. So most of your VMs will have a temporary D drive. The important thing to note about this D drive is that it's ephemeral. It's not guaranteed to be persisted if the VM is powered down, or if it needs to be migrated to a different host because of some kind of, like, say, hardware issue on the host, or some kind of unscheduled maintenance that happens. So you can't put anything on the D drive that you can't replace easily. So this is why it's great for TempDB, because every time you restart SQL Server, TempDB gets recreated. So if the ephemeral drive goes away and there's nothing there, then it's totally fine. The only kind of quirk with this is that we do have to put a folder structure in place. And so if you use the SQL IaaS agent extension, which is the SQL Virtual Machine, the little add-on agent you get when you have a SQL Virtual Machine, we have some jobs in there that can automatically create that folder structure for you whenever the VM restarts if it's not there. So that's kind of one quirk about using it for TempDB, but we can get around that easily with jobs. So temporary disk, ephemeral storage, and that's local. That drive is hosted on an SSD drive that's attached directly to the host. So that does not go through the same infrastructure that your managed disk would go through. So the other disks that you may have are data disks. So whenever you look at documentation for an Azure VM and it's talking about data disks, this can sometimes be confusing, because a lot of times when we think data disks, we think disks that are hosting SQL Server data files, but that's not necessarily the case. In this case, data disk refers to any other managed disk that you attach to the virtual machine. And it's up to you whether you want to attach managed disks and how many you want to attach. So you should have at least one, preferably more than one, for your SQL Server workloads. Obviously, we want to follow the same best practices that we have on-prem, with data files being stored separately from log files. So we do recommend you have at least 2 managed disks attached, one for data and one for log files. And then we're going to talk a little bit later. A lot of times you want to be using storage pools so that you get better IO throughput. And we'll talk about that later in the presentation today. Okay. I guess it's a good time to pause in case there are any questions so far.
Sorry, I couldn't get myself unmuted.
That's okay.
Does that mean that the temporary disk provides better IO performance?
Does that mean that the temporary disk provides better IO performance? That's a good question. It's not necessarily better. It might be faster because it's local to the VM. So generally that drive will have lower latency than your remote storage because your remote storage is going through the network. So of course your mileage may vary, but in general, your latency will be lower on that D drive, on that temporary drive. It's another reason why it's great for TempDB because it is local, so it should be low latency. There are some caveats when it comes to IO throughput and IOPS, and we'll talk about those later in the session.
And that was the only one that we have right now. I don't see any in Slack, but Melody's welcome to unmute and correct me if I'm wrong.
No, no questions in Slack at the moment, but thanks for asking.
Okay, great, thanks. Okay, so as I mentioned, this TempDB drive is hosted locally on an SSD that's attached to the host. So let's talk about how this works here. So we effectively have 3 different levels of provisioning for storage in an Azure virtual machine. We have that local temp drive that I was just talking about. And that goes through the SSD level provisioning, and that is served by the SSD that's connected to the host. And the type of SSD this is could vary between machine series. So, you know, it could be like some super fast, like NVMe device. It could be a standard SSD. And so each series will tell you what kind of hardware is here. And we do have, you know, they're always evaluating new hardware. So when new types of NVMe come out, that, you know, they may offer new series that use that new NVMe. So it can vary what the SSD is, but it's some sort of solid state fast storage attached directly to the host. And so that SSD provisioning is separate from what your remote storage goes through. So then we have this idea of cached versus uncached managed disk. So managed disk is disk that is managed by Azure Storage. So this is provided to you as a service through Azure Storage, and you access this managed disk through the network, and it's a priority network channel. So it's designed to, you know, prioritize that IO traffic so that we can guarantee certain performance levels based on the type of managed disk you choose. But it does go over the network, which is why the local storage can sometimes be faster. So this difference between cached and uncached, this has to do with whether or not you've enabled what's called host caching. And we'll talk more about how host caching works in a moment. But essentially, if you don't have host caching turned on, then your managed disk goes through the network. And so there's disk level provisioning, meaning the disk itself, the managed disk itself, is capable of delivering some amount of IO and throughput. And then it also has to go through the network level provisioning, which is at the VM level. So the VM network level provisioning means there's a certain amount of IOPS and throughput that the VM itself is capable of delivering. And again, this all really comes down to network bandwidth. It's how much network bandwidth is available to that VM. And so there is a different limit. There's a disk level limit for the disk level provisioning, and then there's a VM network level provisioning limit. So your uncached managed disk goes through that VM network, and then your cached managed disk is kind of a combination. So when you turn on caching, we leverage the SSD that's attached to the host along with some memory on the host to provide a caching layer for your IO. So if the IO request is able to leverage the cache, then you still go through the disk level provisioning, but you may hit the SSD rather than going to the network. So again, it kind of depends on whether you have a cache hit or a cache miss. If you have a cache hit, you only hit the SSD. If you have a cache miss, you have to go all the way through the network. So when you turn on caching, it gets a little bit more complicated because you could be hitting really all 3 levels of provisioning for cache disks. Again, I'm going to talk a lot more about this later in the session. We'll talk more about how this caching works. But this is the essential pieces of how storage works on an Azure virtual machine.
So quickly, Pam, someone has asked if you can explain how to recreate TempDB folders with appropriate permissions. Is that a good question for here? Do you want to save it for later?
Let's save that one for later because
Okay.
I do have an article for how to create that job. It's buried in our documentation somewhere, so I don't have it handy. But essentially what you have to do is create like a Windows scheduled job that recreates the folder structure. So I can find that documentation if I have time at the end. Otherwise, just do a quick search for that and you should find it somewhere in our document.
I'll see if I can find it.
Yeah, okay. Anything else before I?
Is the caching tier read write or read only?
It can be either read write or read only. We'll talk more about that in a moment. We recommend for SQL Server data files that you set it to read only, and I'll talk about why later on. Okay. So disk level provisioning, SSD level provisioning, and VM networking level provisioning. So let's talk about the disks first. Managed disks. You have many different options for choosing managed disks in SQL Server. It's worth mentioning here that it is also possible to just create blob storage and host your data files on blob storage. You can do that, but we generally recommend that you go with managed disks because there are a lot of benefits to managed disks. Generally, the performance is better and they support things like snapshots and disk images and things like that. There's just a lot of benefit to managed disk. So we've for the most part removed most of the documentation about hosting your SQL data files on blob storage for Azure VM because there's just so much good stuff with managed disk. So I wanted to say that up front, but all the conversation we're going to talk about today has to do with managed disk. Okay, so I'm going to just take away two things on this slide. Don't even think about standard HDD or SSD. It's too slow for SQL Server workloads. Your choice for SQL Server is between premium SSD or ultra disk. So I will tell you that most customers, premium SSD is going to work for you. If you need more IO and throughput, you can pool premium SSDs together using storage spaces. We will also talk about that later. But you really only want to go with ultra disk if your workload is very sensitive to latency. Ultra disk offers sub-millisecond latency. So if you know that that's something you really need, like maybe for transaction log, if you have an incredibly busy OLTP system, it's super fast and you can't afford a millisecond or two of latency, then ultra disk might be something that you want to consider. The issue with ultra disk is it's incredibly expensive, way more expensive than premium SSD. So you really only want to consider ultra disk if you absolutely have to have that sub-millisecond latency. I want to say one more thing about latency here, and that is I can pretty much guarantee this premium SSD, even if you have storage pools and you got lots of IOPS and throughput, it's probably going to be slightly slower than what you have on-prem. It's probably not a problem though. So most of your SQL Server workloads are not that sensitive to latency. I mean, we're talking like 2 to 5 milliseconds of latency for the most part. So even though it's going to be higher, and sometimes you could get up into the 10 to 15 millisecond latency as well. But I mean, for the most part, your SQL Server should be able to handle that level of latency. There are definitely some workloads that need it to be faster. And so that's where ultra disk comes in. But I would say I've had a couple of customers say, oh, we measured the latency and it's so much slower. And I was like, yeah, but measure your application latency. Is your application feeling that? And then they were finding out that no, actually it wasn't. Even though the storage latency was a little bit higher, their application was fine. SQL Server was handling it, their application was handling it, and it didn't pose a problem. So try not to fixate too much on latency numbers. This probably will be slower than on-prem, but do your testing and see whether you really need that ultra disk or not.
So Pam, is standard SSD, before you move from the slide, is standard SSD a bad idea, even if it's just for dev?
If it's just for dev and performance doesn't matter, it's probably okay. What you're going to find is it doesn't go as high for IOPS and bandwidth and throughput. So it's much lower there. The latency is going to be higher. So it's probably okay for dev, but it depends. If you're doing any kind of perf-related testing where that IO performance could change the nature of the workload, then it could be important. So dev is probably okay, but maybe for perf and functional testing, I probably would even go with premium SSD for that. Okay, So premium SSD, is there some way I can make this little, I need this box to go away. Oh, well, all right. Anyway. Move this or something. Is that blocking, is the fact that my box is there, is that blocking what you guys are seeing?
Which box?
I have this little Zoom control panel, and I just want to make sure, can you guys see the title where it says P30 and P40?
Yes.
You can. Okay, great. Then I won't worry about this. Okay, so premium SSD, production and performance sensitive workloads. And we generally recommend P30 and P40 drives. The reason for that is P30 is the smallest drive where you can do storage reservations. And so if you reserve storage, you can lower your costs a little bit. So that's the smallest drive that you can do that reservation with. And if you go 4 terabytes or larger, you can't use caching. You can't use host caching. Host caching is only for drives that are smaller than 4 terabytes. So generally you're looking at P30 or P40 and usually a pool of those drives in order to achieve the IOPS and throughput that you need. So this is your disk level provisioning. This is how much the disk itself is capable of. So you can see the size in the case of premium SSD, the size is connected to the IOPS and throughput. If you want more IOPS and throughput, you have to increase the capacity of the drive. And so this is where the pooling comes in, because if you want to increase IOPS, but you don't necessarily need that much capacity, then creating a storage pool allows you to do that, and then also allows you to leverage read caching, which we find is very important for SQL workloads. So this is the sweet spot usually for premium SSD, P30s and P40s. You can go up higher if you need to, especially for your log drives, because for your log drives, we're going to tell you you're going to set host caching to none for your transaction log drives. So for those, you can go larger if you need to, but we generally recommend P30s and P30s and 40s for most of your data files. And then, of course, we have UltraDisk. So UltraDisk works a little bit differently. You can actually provision capacity separately from IO and throughput. So you can customize UltraDisks a little bit. And, say you only need a terabyte of storage, you can still move up the IOPS and throughput higher for those smaller drives. So this gives you a little bit more flexibility. You probably wouldn't have to do a storage pool with UltraDisk. You could just get away with one UltraDisk that's large enough for your needs, and then set the IO and throughput according to what you need. But again, and this goes higher. This is just a snippet of the low end of the chart from documentation. So UltraDisk, very customizable. Again, you're going to pay for that low latency, but it's if you need it, you need it. And so that's what UltraDisk is there for. Okay. So we're going to move on now from disk level provisioning to VM level provisioning. So these are your limits at the disk level. There are also limits at the VM level. So what I have for the next couple of slides is a snapshot of the documentation for one of our VM series. This is actually our favorite VM series for SQL Server workloads, which is the EDS v4 series. So when you look at the documentation for a VM, there's a lot of really important information that has to do with storage here. And this is actually a subset of the information that's available, but the important stuff for our conversation is the max cached and temp storage throughput and the max uncached disk throughput and IOPS. So this is your VM network level provisioning, max uncached disk throughput, IOPS, and megabytes per second. This is this first number is how many IOPS the VM can support, and the second number is how much throughput the VM can support. So no matter how many disks you provision and attach to that VM, you may be able to attach way more IOPS and throughput at the disk level than the VM level will support. So it's important when you're choosing a VM size to have some idea of how much IO and throughput you need, and to be able and to choose a VM that's going to meet your needs, not only at the disk level, but at the VM level. So there's really two different limits that you're looking at. There's actually three different limits I'll talk about in a second that you're looking at. You're looking at the disk level provisioning, and here you're looking at the VM level provisioning. But we did say there's a third kind of provisioning, and that's the SSD provisioning. So the SSD level provisioning, this is this max cached and temp storage throughput. So this is how much throughput you're allowed to use on that local SSD that's attached to the host. So this is used both for caching, if you've turned on a host caching, and for your local temp drive, the D drive. So both of those come out of this limit, max cache and temp storage throughput, because that's your SSD level provisioning. The size of the cache is this number in parentheses at the end. And then the size of the local drive itself, the D drive, is what's listed here, temp storage SSD in gigabytes. So when you're choosing a VM size and you're thinking, okay, I want to put temp DB on the local drive, you need to make sure that you choose a size that has a local storage large enough to host your temp DB, however large your temp DB needs to be. And this is one of the reasons why we like the EDS v4 series, because they have relatively large local drives and they have very high IOPS and throughput against the local drive. So, so this is a great choice for IO intensive workloads. It's also part of our memory optimized series, which means it's got a decent amount of memory as well. Okay. Questions there before we move on?
So I have one, not on this slide, we'll get to them at the end. I don't know. Melody, do you have anything from Slack?
One that's being typed. Oh,
Hold on. So while we're waiting for that to get typed, can you mix a P30 and a P40 in the same pool?
Can you mix a P30 and a P40 in the same pool? Yes, I believe you can. I don't know if you'd want to though, because
won't you get billed for the P40?
You'll get billed for the P40 and you'll get billed for the P30, but it's actually for performance reasons, because when you do, and I can probably talk more about this when I talk about storage pools. When you create a storage pool, we want you to stripe across all the drives in the pool. That's what gives you the max IO and throughput. If the drives are different sizes, then you're not going to be able to utilize them equally. Does that make sense?
It does to me, yeah.
Okay, all right, and I'll show more. I do have a slide on storage spaces, so I'll talk more about that.
Okay, and okay. Melody, go.
Okay. The LS32 VMs have NVMe drives. If those drives are considered to be local, do they have IOPS or megabyte caps?
They do. So those LS series VMs, they do have like this local cap of throughput, and they are ephemeral. Anytime you have a local drive, NVMe or SSD or whatever, it's ephemeral. So you've got to keep that in mind for those L series VMs, is that it's not persistent storage. So it's not good to put your data files on there. Now, if you have some kind of a transient workload, like, I don't know, some kind of like a data load process, ETL processing, something where you could recreate the data if it goes away, then you can leverage that NVMe. But otherwise, it's really only good for either TempDB or some kind of caching. So that's one of the reasons why we don't heavily recommend the L series VMs for SQL Server. Okay. All right, so let's talk a little bit about IO capping. That's apparently the preferred term. We've always called it throttling because that's what we're used to talking about, but the storage folks likes to call it capping. So if you hear that term capping or throttling, it's the same thing. That's what we're talking about. So basically, this is the limits that are being imposed on you based on the service level that you've purchased. So you know, you can always like size up your VM if you need to get more. You can add drives, you can size up your drives to get more, but only within the limits of what the series supports. So there may be some capping involved and that you want to be monitoring for, and we'll talk about that. So here's how the disk level capping works. So I've got a series of animations here to try to describe how this works. So we've got our application, which in our case is SQL Server. The example we're using throughout here is the E8 DSV4. Oops, I got a typo on my slide. I got to remember to go fix that. It's E8 DSV4. It's capable of 12,800 IOPS and 192 megabytes per second of throughput. And then we're in this example, we're assuming that we've attached some P10 drives, which are smaller than what I recommended, which was the P30. So the P10s can only go up to 500 IOPS and 100 megabytes per second of throughput. So let's say that our SQL Server issues 10,000 IOPS against the VM storage. So we'll assume that it's spreading it out this way. I don't know. This is just an imaginary example, so I don't know how it would be spread out this way. But let's just assume that it's throwing 4,500 IOPS at one drive, 4,500 at another, and 1,000 at the last one. These drives are not capable of that much IOPS, so they will not be able to return 1,000 IOPS per second. They will only be able to return 500 IOPS per second. So there will be some queuing happening here as these drives try to process all of these IO requests. So you'll only get back 500 IOPS per second, which means that SQL Server is only getting back a tiny fraction of what it needs. And so this is the kind of capping that would probably cause you some major performance issues, right? And this would be capping happening at the disk level. So this is disk level provisioning, disk level capping. So the way you would get around this problem is by creating better drives, right? Either adding more drives to a storage pool or somehow increasing the number of IOPS that are available at the disk level. So if we were to do this example again with P30s, P30 drives can support up to 5,000 IOPS and 200 megabytes per second. So with this example with the P30s, 10,000 IOPS split up as they were before, these disks can handle that, and the VM can handle up to 12,800 IOPS. So no problem, no capping. So with this configuration, we would be okay. Now, keep in mind, capping can happen at either the throughput level or the IOPS level. It really just depends on which one you hit first. And which one you hit first probably is going to depend on the type of workload you have. The larger your IO requests, the more throughput you get. If you have a lot of small IO requests, then you might hit the IOPS limit first. So it really kind of depends on the workload. You can generally separate it out by like OLTP versus data warehousing workloads. Obviously, data warehousing workloads are generally going to have larger IOs. And so with data warehousing workloads, you might be more concerned about throughput. And with OLTP, you might be more concerned about IOPS. Most of the cases we see, or the ones that get escalated to us anyway, I should say, are getting throttled at the throughput level. So that's where we spend a lot of our time thinking in throughput, but I've seen both happen, getting throttled at IOPS, or sorry, getting capped on IOPS or getting capped on throughput. Either one can happen. Okay, so that's disk level capping. What about the VM level? VM level also has a cap. So the VM level's cap is 12,800 IOPS. So going through our example, let's say that our workload increased against our SQL Server, and now we're throwing 15,000 IOPS at the VM. So in this case, I'm breaking it down 5,000 to each P30 drive. Now the P30 drives can handle 5,000 IOPS. So they will return back the 5,000 IOPS just fine. There will be no capping happening at the disk level. However, the VM cannot handle that much. The VM can only handle 12,800 IOPS. Okay, that could cause some queuing. Will it cause enough of a performance issue that you would notice it? I don't know, because it's not that far from the 15,000 that were asked for. So the queue would be relatively small, and it would really depend on how long you were in this situation. So if your SQL Server is constantly throwing 15,000 IOPS at a VM that can only support 12,800, you will probably start feeling an issue. This will start backing up more and more, and you'll be having performance issues. But if this is a one-off spike, maybe this happens only when you do your index rebuilds, let's say, or maybe this happens when you do your backups. In that case, it might be sustainable. It might be something where you see the cap is happening, but it's okay because we recover after a few minutes or after an hour or something like that. It's not causing any application latency, and so it's fine and you can sustain it. So it's really important for you to monitor not only whether or not the capping is happening, but what the effect is on your application. You shouldn't immediately freak out if you see this capping because it's normal. What you should see is what is the impact that's having both on SQL Server and on your applications that are using SQL Server. Because a little bit of capping indicates that you're actually using the hardware that you purchased. You're paying for this hardware whether you're using it or not. So it's good to be kind of close to the edge here on what the VM is capable of. If you get into the situation for a long period of time, then you want to bump up. Maybe you want to bump up the VM size. Okay, so it's normal for it to be happening. It's up to you to kind of figure out whether it's a problem or not. Okay. So I'm going to move on to host caching and introduce how host caching can help with this problem. But before I do that, I'll take another question pause.
What counters would you recommend to monitor or assess the IOPS throughput on premises before migrating to Azure?
Very good question. I have a slide on that a little bit later, right after we talk about host caching. Yep.
What size are the IOs for VMs or disk caps?
What size are the IOs? So, I mean, SQL Server is going to throw a different size IO depending on what your workload is. So we don't know what size IOs are actually going to happen. Off the top of my head, I'm not sure what the IO size is that they use to calculate this, but you could probably figure that out by doing some math, which I can't do in my head right now because my head is in the presentation. But if you take the throughput limit and the IOPS limit, you could probably figure out based on that how much what IO size they're using as an example for the calculations, for the capping calculations. But like I said, there's no fixed IO size for SQL Server, so your mileage is going to vary as to which way you get capped.
Okay, is there alerting that can be configured to know when a disk or VM is hitting its cap?
Yes, there is. I will talk about that at the end, and hopefully, if we have time, I'll do a quick demo.
Okay, and at what block size are the IOPS calculated, 4K or 64K?
The IOPS calculated for the capping limit, or so that's what I was saying, like 4K, 64K. SQL Server is going to throw what it's going to throw. Oh, you mean like the actual IO requests? Like how it, sorry. Like if Windows generates like a 4K request, does that what counts as an IOP?
He says yes.
Okay. I think that's going to depend on how you configure your storage and what you set your block size to, which we recommend for SQL Server as 64K. But that level of detail, I'm not quite sure about. So that might be something you need to follow up with me on Twitter about exactly how we calculate that.
Okay, he will. Thank you.
Great. Okay. So let's talk more about this host caching, because this host caching can really come into play here with VM level provisioning, because it's just one more layer of assistance you can get on IO. Okay, so host caching is set on the disk, but it's really a VM level technology. So this host caching, as I mentioned earlier, is in the VM. It leverages the SSD that's attached to the virtual machine host, and as well as some memory from the host, and it uses that to form an IO cache for your managed disks. So you would turn this on at the disk level. When you build a VM, you will have that OS disk gets created automatically. It'll automatically be set to read-write caching. We recommend that you just leave that alone. For your data files, we recommend read-only caching for your disks that host data files. And for your disks that host transaction log files, you should set caching to none. The reason for this is you can do read-write caching. However, SQL Server force flushes IO to the physical storage, which means we cannot honor write caching. We can't do write caching. We have to guarantee, in order to guarantee durability, we have to guarantee that the write went all the way through to the disk. So because of this, we cannot take advantage of this kind of write caching. So you have to set it to none, because even if you set it to read write, we wouldn't be using it, which means you'd be wasting a huge amount of cache, and we're force flushing everything down to the physical storage. So you would be wasting space in the cache, and you'd also be wasting cached IOPS that would better be used serving your read workload. So not only do we recommend this, I'm going to tell you it's actually a bad thing if you turn on caching on your log drives. It could cause you actually performance issues. So none for your transaction log files, and disks hosting data files, read only caching. Again, because even on your data files, we have to do that force flush where we go all the way to the physical media. So you can't leverage write caching at all for any IO in SQL Server. So always for SQL Server data files and log files, for SQL Server data files, read only caching, and for log files, no caching. Okay, so here's how the caching works with the provisioning. So if you have read-only caching turned on and you're doing a read and the data is not in the cache, the read request checks the cache, and then it checks the disk itself because it's not in the cache, and the read response comes all the way through. So this means the read counts toward the cached limit and the uncached limit, because the IO had to go both places, first to the cache to see if it was there, and then to the remote storage when it didn't find it in the cache. So that IO counts for both limits. If the data is available in the cache, the read request hits the cache, comes back from the cache. We never go to the remote storage. Therefore, this read is counted toward the cached limit on the VM, but not the uncached limit. So this is where read caching can really be a benefit for SQL Server workloads, because when you choose a VM that is capable of doing caching, if you don't turn caching on, you're leaving IOPS and throughput on the table because you won't use it unless you have your caching. Now, you might use it for your tempdb because we told you that it's a best practice to put tempdb on the D drive. So maybe you'll be able to use that IO throughput for your tempdb. But if your tempdb isn't using it all, then if you don't turn on read caching, you're leaving money on the table. So it's really important to understand about how this read caching works and how these different provisioning limits work, because you want to get the biggest bang for your buck. You're paying for this VM, it's got caching as built into the VM itself. Turn it on, or you're really kind of hampering the performance that VM is capable of. Okay. So for writes, write operation hits the cache and also eventually has to hit the uncached, hit the remote storage as well. So writes are counted towards the uncached and the cached limit. Okay, so this is how you can think about how the cache is going to impact where your provisioning is coming from. This is another one of the reasons why let's not do write caching, because it's not going to benefit from us. So we don't want to be taking away from these limits if we can't benefit from it. So no write caching for SQL Server. Okay, so great. I'm actually going to skip that because I just told you no write caching. Okay, so let's look at the benefits. How does this help you? So we're tying this all together: disk level provisioning, now SSD level provisioning, and VM level provisioning. So same setup. We have that standard E8DS v4, 12,800 IOPS, and 192 megabytes of throughput. Check out the cached throughput though, 77,000 IOPS cache throughput and 485 megabytes of cache throughput. So this is a lot of local storage and a lot of cache throughput, much more than what the remote storage is capable of. So with this, we've got our 15,000 IOPS coming from SQL Server. We send that down through the host cache to the P30 drives, which all are set to read-only caching. These are where our data files are. And now all 5,000 of those IOPS come back, right? Because disk level provisioning, they're capable of 5,000. But now, because the host cache was able to absorb some of those IOPS, we can send all 15,000 IOPS back to SQL Server. We could handle it because the cache made up the difference. Okay. Now, this is all obviously theoretical. Whether your workload can benefit from caching or not is going to depend, but we are finding that most customers get at least a 30% improvement in throughput simply by turning on read caching. So I've never had a case where I've told a customer to turn off read caching. I have had some cases where their tempDB workload was so high that it was conflicting with the read caching, and they were hitting their cache limits because both their tempDB and their caching was high. In that case, they moved tempDB onto a remote drive, and they just leveraged that for host caching. So again, your mileage may vary. It's going to be important for you to understand what your IO patterns are to know how to configure this. But for us across the board, we're saying best practices: set your data drives to read-only caching, put your tempDB on the local drive. Usually there's plenty of throughput to go around, especially if you're in one of these EDS v4 series VMs. Okay. All right. So I don't think I saw, I'm kind of trying to keep an eye out. I don't think I saw any additional questions come in. Do you guys have anything for me before I move on?
I have one. I'm not sure that you're gonna be able to answer it. Any plans for persistent memory disks for the transaction log for Azure VM hosted SQL servers? And the answer can be, we don't comment on roadmap, but you know.
I mean, if I had something solid that I thought I was going to deliver, I would comment, but I don't know of anything. And also keep in mind, we depend on what Azure VM is going to offer. So if Azure VM comes up with a new VM size that has PMEM, then we'll think about you know, how that would fit in with SQL Server. So I don't have anything I can tell you today.
I have one other one. Azure Storage calculates IO in 128 KB targets. Anything larger than that counts as a split, which oddly is not a question, it's a statement. So
okay, well that's good to know, because that's something I didn't know off the top of my head.
Okay.
No questions in Slack.
Cool, thank you. All right, so let's start tying in what we talked about so far with how the Azure Virtual Machine Storage works and how you're going to map that to your workload. So once again, I've got that documentation on the slide here, and this is the VM we've been looking at in the examples, the E8DS v4 with the 12,800 IOPS at the VM provisioning level, 77,000 IOPS at the SSD provisioning level, and then our P30 disks with the 5,000 IOPS at the disk provisioning. So here's that diagram again, and here I'm mapping the documentation for the various pieces with how this is laid out. So you can see my P30s support 5,000 IOPS and 200 megabytes per second of throughput. That's your disk level provisioning. That's how much each one of those disks is capable of. Then we've got the SSD level provisioning. Based on this max cached and temp storage throughput, I can say that the SSD is capable of 77,000 IOPS and 485 megabytes per second of throughput. So that's our SSD level provisioning. That provisioning is split, as you can see in the diagram. That is split between the local drive and any drives that have caching enabled. So they will share that IOPS and throughput. The size of each one of these also is listed in the documentation here. So the temp storage SSD here, it's 300 gigabytes. So that means this D drive will be 300 gigabytes. That's separate from the 200 gigabytes that's available for the cache. So this means you'd have 200 gigabytes available for cache, 300 gigabytes available for the local drive, which in theory, we're going to say you're using for tempdb. So that's how much size you have on the local drive, and this is how much IOPS and throughput. Then the VM level provisioning, that's this number, max uncached disk throughput, and that's your 12,800 IOPS and 192 megabytes per second. So that's the VM level provisioning. So this is how you can think about the various limits. And as I said, you can get capped at any one of these depending on which one you exceed, okay? So I think I already kind of talked about this as I was going, but here we recommend transaction log files, host caching none. So this would be uncached. So your transaction log files, all the IO going after your transaction log is probably going to be capped by either the disk provisioning or the VM provisioning, because you're not going through the cache. So you have to think about both this disk provisioning and VM level provisioning for the transaction log files. Data files, we said turn on read-only caching for all the drives that host data files. So for read-only caching, you're looking at a combination of the disk level provisioning, the SSD level provisioning, and the VM level provisioning. And then for tempdb files, local drive, no caching. This is only hitting the SSD level provisioning. So any IOPS for tempdb are going to count towards this limit. Okay, so let's tie that all together. Someone asked me earlier about what counters should I be monitoring. It's actually quite simple. Perfmon is your friend here. If you're on Linux, I've got your IOStat counters here. So your IOPS, or transactions per second, the number of IO requests issued to the storage per second. This is your disk reads per second and disk writes per second. Throughput is the amount of data that's written to or read from the disk per second. This is disk read bytes per second and disk write bytes per second. And then latency, as I talked about, you do want to have an idea of where your latency is at on-prem. It's probably going to be slower in Azure, but if you want to see where you stand on latency, that's average disk seconds per read and average disk seconds per write. I do recommend that you monitor tempdb data files and log files separately, because I'll just go back one slide just to remind you that they're all going to kind of hit different limits here. So it's important for you to understand the nature of each one of those types of IO for your SQL Server, because they will map to different capping limits. So this is totally theoretical. You're never going to get the math to work out here. However, just to give you an idea of what you need for sizing, uncached IOPS and throughput roughly maps to your transaction log reads and writes, plus your data file writes, and let's say 70% of your reads. Based on that number, like I said, we've been seeing about a 30% boost in throughput from read caching on most SQL Server workloads. So I'm this is like a pulling clear out of the sky number. But if you really want to think about how much host caching is going to help you, I can say, let's say only count 70% of your reads on data files. Totally, your mileage may vary, but that's my back of the napkin math there. Cached and local IOPS and throughput, this roughly maps to your tempdb reads and writes, plus your data file reads. All your data file reads, because even if they're a cache miss, they're still hitting the cache limit. So all of your data file reads, but not the writes, because you're only going to turn on read-only caching. So all of your data file reads, and then all of your tempdb reads and writes. So if you want to get an idea of what you would need in Azure for your virtual machine, you can monitor these counters over time on-prem, and you can kind of map them to the limits, to the different limits for the different levels of provisioning we have here. I didn't leave disk provisioning. Hopefully that's pretty straightforward. Obviously, whatever disks host your transaction log files, you would also need to make sure that your transaction log reads and writes fall under the limits for the disk provisioning. And like I said, you can have multiple disks in a pool, so that can be more than one disk. So this is roughly what you want to be looking at. we do have tools that can help with this. We have a new SKU recommendation tool that comes with the data migration assistant, data migration service. Anyway, there's a new console app for the SKU recommendation. Everything that David and I researched over the last year, we poured it into this SKU recommendation tool. So it does all of this back of the napkin math that we've been talking about, and it spits out a recommendation of SKU based on these perf counters. The other thing to note is you need to be looking at average over time, and you need to be looking at your spikes and how long your spikes last, because you don't necessarily want to get a VM that's sized to the highest spike if that highest spike only lasts for 10 seconds once a month. You probably want to size smaller and hope that caching and other things get you through that spike. Otherwise, you're kind of wasting your money on hardware that you're not using. So you do need to monitor over a long period of time, and you need to look at averages and maximums to kind of pick a size that makes sense, that will get you the performance you need, but not cost you too much money in the long run. Okay. I'm going to assume there's a couple of questions based on this, so probably another good time to pause.
Okay. How can I diagnose if my workload is hitting this IO limit?
Oh yeah, good question. I'm sorry. That slide's coming up.
Okay. And then I have some that will probably hold till the end because they're from earlier sessions. Joey D'Antoni found that link that you referenced earlier about TempDB, so I answered it.
Oh, brilliant.
So Joey found it. Yay. Okay, so Melody, do you have any questions?
What is the SKU tool called?
It's called the SKU recommendation tool. I should have had that link handy. I'll try to dig it up, but if you guys can find it, let me know. Otherwise, I'll find it after and I'll dump it in the chat, or I'll tweet about it.
Okay, I do have another quick question. Can you add a drive to the pool? And if so, is that an offline operation?
Can you add a drive to the pool, and is it an offline operation? Yes and yes. Here's the thing. You can add drives to the pool online. However, it only increases the size of the pool. It increases the capacity, but it doesn't increase the IOPS and throughput. And I'll talk about that in a minute when we talk about storage pools, but basically we need to stripe across all the drives in the pool in order to maximize the IOPS and throughput we're getting from that pool. If you want to increase the IOPS and throughput of that pool by adding another drive, you need to restripe across the new set of drives. So you actually need to create a new pool and migrate your data from the old pool to the new pool. If all you want to do is add capacity, you can just add drives, but then you really need to add drives in multiples of the original. It's called the column count, which is the number of drives that we're striping across. So if you originally had 4 drives in the pool and you're striped across all 4 drives, if you want to add capacity to that pool, you should really add 4 more drives so that we can continue to keep that striping the same. Otherwise, you could have a reduction in performance. So I don't think we're going to have time today to dig really deeply into storage spaces, but if you look up storage space documentation, there's some more conversation about how that works. All right. So as I said, SKU recommendation tool, I'm pretty sure it's GA, but maybe it's preview. So maybe it's something that that you might have to ask for, but I'll make sure that it's definitely coming if it's not already GA. If you don't know, use one of our tools, or here's just some baseline VM series that we like. The EDS v4 series, my personal favorite. This is the best price performance for SQL Server workloads. It's got a decent amount of remote throughput, one of the highest series out there. It's got the right mem to core to memory ratio of 1:8. So most SQL Server workloads, we're finding that's the sweet spot, is 8 gigs of memory per core. So it's got that 1:8 ratio. And it's got that huge amount of local throughput. This is just such a great series. So if you're not sure, this one is usually the best price performance. M series VM, this gives you more memory per core. So it's a lot more memory, and it's the highest IO throughput available in Azure. So for your really high-end workloads that need a beast hardware M series is the way to go. And this includes many different kinds of M series, MV2 series, MS series. There's a bunch of different M series VMs. All of them are mission critical systems, giant data warehouses, things like that would go to M series. The issue with M series is they're quite expensive, much more than the EDS v4 series. So even if you have to go lower on the RAM, you might be better off starting with the EDS v4 rather than going straight up to an M series. But if you need it, the M series is there. And then entry level, small SQL Server, not a huge workload, DSV2 series 11 to 15. This one's a good entry level SQL Server VM. But I always say, when in doubt, if you have no idea what to do, go with the EDS v4. This is absolutely the best price performance for you for your SQL Server workload. So if you just really don't know where to start with the EDS v4. Okay. All right, some storage best practices. So storage spaces. So we've already talked about this quite a bit. The idea here is if a single disk is not enough for the disk level provisioning, and we're talking single disk for transaction logs, single disk for data files, if that's not enough, then you can pool disks together to get higher IOPS and throughput at the disk level. So obviously you want to be careful not to over provision here, because you don't want to provision so much disk level capacity that you exceed what the VM is capable of. However, if you think that you're going to grow in the future, it may be okay to provision tons of disk level provisioning, because it's harder to upsize your disk IOPS and throughput than it is to upsize the VM. So you could always upsize to a higher, a larger VM and then have more VM level throughput. But if you want to upsize your disk level provisioning, like I said, it's an offline operation. We have to rebuild the pool. So you may over provision disk level if you want to have a ramp for growth, but it's up to you as to what you think your workload needs. So generally, what we find is having a storage pool with multiple smaller drives is more cost effective than a single larger drive. So here's an example. One P50 gives you 7,500 IOPS and 250 megabytes per second of throughput with 4 terabytes of storage. That costs you $450 a month in East US 2. A storage pool with 4 terabytes with 4 P30 drives cost about the same, $491 per month. But look at how much more IOPS you get. You get 20,000 IOPS and 800 megabytes per second of throughput. So it's the same capacity, but you get a lot more IO throughput if you stripe it in a storage pool for about the same money. So for when it comes to price performance, usually going with P30s or P40s and striping them together in a storage pool is going to give you better bang for your buck than a single drive that meets your capacity needs. So really you want to be sizing for IO throughput rather than just capacity. Okay. All right. So let's tie this all together. Let me just let the animation play. I actually don't like the animation on this one. Oops, come back. Tie this all together. So choose the right disk, disk level provisioning, premium disk or ultra disk if you really need low latency, P30s and P40s for most of your needs. You can go higher than P30 for your log drives because you're not going to need caching. So remember, you can only do caching if it's less than 4 terabytes. So that's why P30s and P40s. Ultra disk if you need low latency, then you don't, there's no caching on ultra disk, but you shouldn't need it for ultra disk because you can provision IOPS very high for ultra disk. And then your ephemeral disk should be used for TempDB, the D drive for TempDB. Enable the host cache. I can't say this enough. If the VM is capable of host caching, turn on read-only caching on your data drives. Otherwise, you are leaving money on the table. So turn it on for your data files read-only, for your log files none, and TempDB, you're usually going to have it on the D drive, but if for some reason you have to put TempDB on a remote drive, either because of sizing reasons or because of throughput, then you would turn on read-only caching for TempDB as well. If you are on one of those M series VMs, they have something called write acceleration. So if you happen to be on an M series VM, turn on write acceleration for your log drives. So that will give you a much better latency on your log drives. So you don't, if you're on an M series, you may be able to avoid using UltraDisk by using write acceleration again. It only works for M series, though. It's only available on M series. So you refer to the documentation there to see what the restrictions are. And then if you don't remember all of everything I said, leverage the storage configuration. We actually have a built-in storage configuration wizard in the marketplace that you can use when you're provisioning a VM. And it does all of this for you. There are some gotchas here. There are some things that we really want to improve with this. So this is actually an area that we are focusing on now and in the future to make this much more useful for customers and to correct some of the issues that it has. But what this will do is create the storage pools for you with all the proper settings. So you don't have to do the storage pools yourself. You just tell us how many disks you want in the pool. We'll tell you what the total IOPS and throughput is, and we'll build the storage pools for you. So we make this easy for you. And also you can just tell us, do you want to put TempDB on the D drive? Okay, we'll do that for you. And we will create the job, the scheduled job that recreates the folder. We'll do that for you with the IaaS extension if you use a marketplace image and go through the storage configuration wizard. So this is a great way to kind of just have us do stuff for you. Okay, a couple of common pitfalls I wanted to cover before we end. Leading with CPU and memory. The way people tend to pick their VMs is they say on-prem, I have like 8 cores and a terabyte of memory. When I go to Azure, I'm going to look for a VM that has 8 cores and a terabyte of memory, and I don't know, I'll figure out the IO later. It's really not the right way to size. You'll find yourself probably getting a much bigger VM than you need by doing it this way. So you really want to look at the workload itself. You don't want to buy too much hardware, size for the workload. So do your due diligence of monitoring those perf counters. And David has done several videos on this. So we've got a number of data exposed videos that you can go back and refer to where we talk about how to do that sizing. And also we've documented this as well. In our documentation, we have a page dedicated to sizing that talks about collecting baselines and things like that. In fact, I think we even have a separate page for collecting baselines and what are some of the counters that you should collect. So all of this is in our documentation. Storage configuration, again, following all these best practices, turning on the read caching, making sure you pick premium SSD, making sure you pick a premium SSD that supports read caching. All of that is incredibly important, and those decisions have to be made up front. A lot of times it's hard to correct them once you're in a VM because it involves copying the data from one drive to another. So you want to get that right up front. I'll mention burstable really quickly. I didn't talk about it. There are many disks that support bursting, and there are VMs that support bursting. So we have bursting at disk level provisioning layer, and we have bursting at VM level. The problem with bursting is most of the bursting that's available, it only works for 30 minutes. And the free bursting, you get like a burst bucket. So only when you're saving IO, it fills up the bucket, and then you can burst for as much as 30 minutes or until the bucket is empty. So honestly, for SQL Server workloads, bursting isn't usually a benefit because you only get it for 30 minutes and then your performance tanks. So your mileage may vary on bursting. It's nice to have to kind of help for one-off spikes, but it's not something you necessarily want to rely on. The other thing is a lot of times you need to make sure you're getting the newest generation, the Gen 2 VMs, because you see some stars in the documentation, like there'll be like 2 asterisks. And then if you look at the footnotes, it'll say, we only guarantee this in Gen 2 VMs. So make sure that you look at that documentation and that you're getting what's in the documentation. If you need a Gen 2, make sure you have a Gen 2. And then SQL Server IO best practices, the same things you're following on-prem. These are the things that you still want to be doing in Azure VM. After all, it's still SQL Server. It's the same product you're running on-prem. So best practices like, instant file initialization, turning off auto shrink, all of those kinds of things, you want to follow all those. Turn on data compression if you can. Anything you can do to minimize your IO is going to help you out here. All right, last topic, which I've been promising for a while, is the metrics. And so you can use Azure Monitor to see whether your workloads are getting throttled or not. You can use Azure Monitor, you can use Perf Insights. So what I wanted to quickly show you is the metrics here that are available. And let me bring up my dashboard. Okay, so this is my Azure portal dashboard. And you see here, I have a throttling metrics graph here. Let me just click on this. I have a couple of different counters here that I'm monitoring. So you can see VM uncached bandwidth consumed percentage max. So this is, is there any way I can see the whole thing? It's hard to see the whole, there we go. VM uncached bandwidth consumed percentage. So this is how much of your VM level provisioning you are using. Uncached bandwidth consumed percentage. So VM level throughput provisioning. So if you hit 100%, you're being capped. So we have counters for cached bandwidth, uncached bandwidth, uncached IOPS, cached bandwidth, cached IOPS, and we also have disk level provisioning and cache hits and misses against your host caching. So this premium data disk cache, this is the cache for any data disks that you have attached. So that's that host caching we've been talking about. So hits and misses there. And then we also have, these are your OS disks, but you're looking for data disks. So data disks, disk level provisioning, here's your data disk IOPS consumed percentage and bandwidth consumed percentage. So these counters will tell you whether or not you're being capped at the disk level. And then you've got the cached and uncached VM level capping. So these are the metrics in Azure Monitor that will tell you whether you are getting capped or not. You can create yourself a dashboard like I have. So if you go to your dashboard, you can just like create a new Azure Monitor tile, and you can add whatever counters you want. So I've added the VM level counters here, and you can monitor this way. You can set up alerts if you want to. If you have alerts configured in Azure Monitor, you can build alerts for this. Like I said, Perf Insights is a tool in Azure that will also tell you whether you're hitting these limits. So there are different monitoring tools in Azure that you can use. This is the one that I use most often. Okay. So I don't have a lot of time to dig deep in here, but I know that there were some questions about how do you monitor this. So hopefully that answered them, but has anything else come in?
So about 5 minutes left, but Anthony said you're the last one, so you can go a little over. Okay. And somebody has asked, does Microsoft provide a workload baselining tool that can be used on-prem to help size the same server for Azure? And yes. I know we touched on that a little bit.
Yes, so we have the data migration service. So the Azure data migration service can do this. It can monitor your on-prem workloads. It can do the monitoring for you, or you can load data into it. As far as I understand, I don't know the details of how exactly it works, but like I said, that we've been taking everything that we've learned and kind of putting it into that tool. So the recommendations that it spits out are based on everything that we've talked about today. So, so you can use the data migration service. The data migration assistant is another one that can help you monitor on-prem workloads and then make SKU recommendations for you. And that's that SKU recommendation tool that I was talking about. So yes.
Okay. Melody, did you have any questions in Slack?
I'm not seeing any.
Okay. Okay, so I have 2 questions that came from the beginning of the session.
Okay, let me just wrap up one more slide, and then we'll pick up those last questions. So I really just wanted to kind of tie everything together in a single best practices slide. So the first thing is obtain your perfmon source metrics to optimize your target storage. So make sure you get those metrics we talked about. Like I said, it's all documented in our VM documentation, the counters to collecting baselines, the methodology, and then how you map that. Also, David, literally we just did a data exposed, I think it was last week. So the recording is on YouTube for how to kind of map your on-prem IO to potential Azure VM. Choose the right disk. So make sure that you're choosing the premium SSD and that you're getting enough IOPS and throughput to sustain your workload. Isolate the files. So we do still want to have data, temp DB, and log separately, not only for all the reasons that you've always done it, but also because of the caching settings. Remember, we want no caching on the log drives, and we want read-only caching on the data drive. So it's even more important to separate them when you get to Azure VM. Enable the host cache. Otherwise, you are leaving money on the table. If your VM supports host caching, turn on read-only caching for your data drives, okay? Follow all the SQL IO best practices you've always been following. They are all the same. The 64K block size, all of that stuff, none of that has changed. That's all still very important and even more relevant in Azure, where you're renting hardware, right? Leverage that ephemeral drive. There are some folks that have been kind of afraid to use the D drive because it is ephemeral. We can get around the fact that it's ephemeral. It's ideal for temp DB. Again, if you're not using that D drive and you're not using read caching, you are leaving a huge amount of IO on the table that's really free for you to use because it comes with your VM. So make sure you leverage that ephemeral drive and or the read caching. Configure the storage wizard so you can use our storage configuration provisioning tool to do a lot of this configuration for you. It's especially helpful for getting the storage spaces configuration right. There definitely are some limitations there. And like I said, we're working on improving that. But for most of your cases, that storage configuration can save you a lot of time and headache. And then the last is leverage Azure Monitor to look for those counters around capping. And again, don't panic. If you see your IO getting capped like once a day for a tiny amount of time, it's probably not causing you a perf issue. What you're looking for is capping that happens for a long period of time, or where places where you're pegged at 100% across the board. Those are the ones that you want to worry about. A little bit of capping once in a while is normal. Okay, but Azure Monitor will help you figure out where you're at on that spectrum. Okay. So I'm ready. We can go back to questions now.
Melody's got one first.
Okay.
Do I need to be concerned about failures when adding disks in a pool?
Do I need to be concerned about failures when adding disks to a pool? Do you mean if you have a production like workload and you're adding drives on the fly? I'm not sure what we mean about failures.
Hey, Pam, that was for me, Anthony.
Okay.
What I was thinking about, traditionally, like in a RAID set, we'd have to deal with, we'd have to be concerned about the availability of the disk and there's protection at a RAID level. But if I'm adding disks to a pool, do I need to be concerned about the availability of a disk disappearing? Because then the whole volume would disappear, right?
Yeah. So our recommended settings for storage spaces are no parity. It's just simple volume striping. Right. So if you add a disk, you're only adding capacity. We're not rebalancing parity. We're not doing anything under the covers. You're just adding something onto the pool. So honestly, for most cases, it doesn't make sense to add to an existing pool. Unless, like I said, unless you if you had if you were striped across 4 drives and you add 4 drives because you need that capacity, that works. But any place else, it's probably not going to help you. So I'd say for the most part, you're probably not going to be adding a drive. But we're not doing any kind of data movement, so it should be fine if you do add.
Cool.
Okay, so let's see. Can remote disks be considered like NAS disks?
Yes, yes, you can consider them like NAS disks. They are going over the network. That's how we're communicating with those disks.
Okay.
The protocol is slightly different. We're not using like SMB or anything like that, but yeah.
Okay. Does recreating that tempdb folder structure delay the instant start? Slow or delay the instant start?
So does recreating the temp folder structure slow or delay the instant start? No, it shouldn't. But we have had some cases where the job did not run before SQL tried to start, and then SQL couldn't start. So we've looked into doing things like delaying the SQL Server service start, just a few seconds to make sure that the scheduled job happens first. But honestly, it doesn't happen that often. We say that these drives are ephemeral, but if we have an unplanned outage, we try everything we can to preserve the drive. So the amount of times that you lose it should be relatively small. Because if you just restart the VM, it's not going to automatically go away. It only goes away like if you shut down the VM or if there's a major outage on the host. So it doesn't happen that often. So you shouldn't be worrying about it. Like it shouldn't affect your normal like failovers and things like that.
Okay. Last question that I have here in Zoom. If tempdb is on the D drive, then its IO doesn't count concerning VM IO capping. Correct.
It not for the uncached cap. It counts towards the cached cap. So remember, there's the VM level provisioning and then the SSD level provisioning, which is also at the VM level. So it counts toward the SSD level provisioning, which is the cached and local storage provisioning.
What are your, sorry, go ahead.
No, I was going to say I have no more questions.
Oh, what are your thoughts about hosting a buffer pool extension on the ephemeral drives next to the tempdb?
We did some testing with that and we did not find it to be an improvement. For now, you're going to do better with ABC caching and tempdb there. So I do not recommend putting buffer pool extension there. Good question, by the way. It's one we asked ourselves and we tested it and no.
Nice. That is all I have. If you have anything else in Skype, I will ask, I don't know, Andrew or Anthony or somebody to pop back in here.
Okay.
Yes, absolutely. If we get any more questions, we will forward them on to the speakers.
Cool. And then I'll leave you with my little shameless plug slide, and then I'll let you guys put up your QR code. One thing I wanted to point out is Pedro created this aka.ms SQL shortcuts. It's just a list of some helpful links. So you can go there. I'll have to go in there and add some VM stuff. I don't know if there's much VM stuff in there, but this is my standard good stuff slide. So thanks, everybody. I really appreciate being able to be here today. Like I said, it's my favorite virtual event. So I'm really glad.
Fantastic. No, that was a fantastic session, Pam.
Yeah,
we're looking at setting up some nodes in Azure for DR purposes for our AGs, and that the slides you had there are absolutely golden. So we'll be going back and reviewing those 100%.
Great. Thanks, guys.